Day 32, page 759, problem 23. Here's a scenario where we have to read carefully and imagine or draw, and also imagine the situation very carefully. We have a wire that's kind of like the way I read it, kind of like a telephone pole. It's a wire that's vertical with respect to the ground. And it says it's carrying an upward current. That means, to me, what that means is towards the ceiling. So if I draw that, here would be the wire from a bird's eye view with current going towards the ceiling. So that would be 15 amps of current going towards the ceiling. And you're going to put a little compass. Now it's going to be a vector problem as well. You're going to have two B fields, two magnetic fields in the same location. And hopefully this is easy the last one where they canceled out, which I doubt they're going to cancel out. So we have to be real careful here. But you have two magnetic fields. You're going to have a magnetic field created by this wire, and you have the magnetic field created by the Earth itself, the naturally occurring magnetic field. So we have a little bitty compass over here. And the compass, I'm not going to draw the compass, but the compass is detecting a magnetic field that is 10 centimeters away. Up, let's say it's just north of the wire. I'm going to draw that. So from a bird's eye view, what that is showing, I'll use blue, is a magnetic field, Earth's magnetic field. That's right here. Let's say that's the 10 centimeter mark. So the Earth's magnetic field is due north. That's 0.5 times 10 to the negative fourth Teslas. That's the Earth's magnetic field at that location. And that spot is 10 centimeters north of the wire. Now, using the right-hand rule for the wire, the magnetic field created by the wire itself is counterclockwise around this wire. And I wouldn't normally draw this, but as we go out from the wire, let's go closer to the wire, this black circle would represent magnetic field around that wire. And as you go further and further out, what you got to look at, though, at any given spot on that circle, the magnetic field is tangential to that circle as you go around that wire. So once again, that black circle that I drew represents magnetic field circling around the wire. But as I make that circle bigger, I'm not going to draw another bigger circle, but if I did, at the reference point, that magnetic field would be towards the left. That's the tangent to that circular magnetic field at that spot. That's B sub 2, or the magnetic field created by the wire at that location. And then B sub 1 would be the Earth's magnetic field. So we got to add those two vectors. It's pretty easy to add two vectors that are at right angles because you can Pythagorize it. But bottom line, B sub 2 is mu 0 over 2 pi times I over R. So B sub 2 is 2 times 10 to the negative 7th times the current in the wire, 15 amps, divided by the distance you are from the wire, once again in meters. That's 0.10 meters. So do that calculation. I'll give you B sub 2. And bottom line is, I'll draw the vector diagram. You can calculate that numerically. But the net result is you're going to take your two vectors, and here's one way to draw it. You have your Earth's magnetic field, 0.05 times 10 to the negative fourth, and your answer to the one you just did, B sub 2. So your net resulting magnetic field will be the sum of those two vectors. It's going to be in that direction. That's your answer right there, B sub t, B total. If the two answers came out to be the same, or the two contributing vector fields, the 0.5 from the Earth and the B sub 2 were equal, then it would just be 0.5 times root 2, but I doubt if they're both going to be equal. Anyway, just Pythagorize that to get the total magnetic field, and you could get a direction as well. So it says determine the equilibrium direction of the compass needle. So you'll have to figure out how far that angle is from north, in other words, theta, because the compass is measuring the combined two fields. Initially, it measures the Earth's magnetic field, but then when you introduce the second magnetic field, it'll combine them and it'll point in the direction as I indicated in my diagram right there.